Gazing upon Jupiter is like admiring a masterpiece, a swirling canvas of cosmic art painted by nature itself. But what many don't realize is that the very act of sending a spacecraft to study this magnificent beast is an incredible art form in its own right, a dance of physics and engineering on a grand scale. This colossal planet sits an average of 628 million kilometers away from us, and in a way, it acts as Earth's silent guardian, a role it has played for billions of years. Its immense gravity acts like a cosmic slingshot, deflecting the paths of countless hazardous asteroids and comets that could have otherwise set a collision course for our own world. As the largest planet in our solar system, Jupiter is a time capsule holding the pristine secrets of our solar system's chaotic and fiery birth. However, unlocking these secrets is an immense challenge. Sending a spacecraft to study this gas giant is far from simple, as the vast distance and Jupiter's terrifyingly powerful radiation belts make it one of the most hostile environments imaginable for any robotic probe. To date, only 9 spacecraft have managed to say hello to Jupiter, with most of them being brief flyby missions that only caught a fleeting glimpse. But this story isn't about those fleeting visits. Instead, it's about one of the most complex and ambitious missions NASA has ever undertaken, launched exclusively to unravel the mysteries of this giant world. We are talking about the Juno spacecraft, a $1.5 billion mission that, in 2021, celebrated a full decade in the harshness of space. Today, we'll embark on an incredible voyage alongside Juno on its groundbreaking journey to Jupiter. So, prepare for launch. On a sweltering summer day, August 5, 2011, at Cape Canaveral in Florida, the Juno probe sat secured atop a powerful Atlas V rocket, ready to begin its 5-year-long trek across the solar system. Juno was a marvel of engineering, a craft specifically designed not just to study the origin and evolution of the gas giant, but also built like an armored tank to withstand the unforgiving environment of extreme radiation it was about to enter. With a roar of fire and smoke, the journey to the 5th planet from the Sun began. But the path to Jupiter was anything but a straight line. It required a clever and complicated trajectory to get there. Initially, Juno was launched onto a path that took it far out into the solar system, well beyond the orbit of Mars. Then, after traveling through deep space, it fired its engines in a series of precise maneuvers that guided the spacecraft back towards its home planet for a crucial gravity assist. In October 2013, Juno swung past Earth, using our planet's gravity like a slingshot. This flyby boosted its speed by a staggering 3.9 kilometers per second, finally flinging it onto the correct course for its distant target. Now hurtling through space at a blistering 93,000 miles per hour, Juno continued its long and lonely journey for over 2 more years. To conserve power and protect its systems during this quiet cruise phase, the spacecraft was put into a safe mode, shutting down all non-essential instruments. At last, in January 2016, Juno began its final approach. During this approach, it treated us to a spectacular time-lapse video showing Jupiter growing ever larger, with its 4 major Galilean moons, Io, Europa, Ganymede, and Callisto, dancing in their orbits around it. This breathtaking sequence was captured from a distance of 4.8 million kilometers, just 5 days before its arrival. Finally, on July 4, 2016, after a 5-year voyage covering billions of kilometers, Juno reached Jupiter. At the moment of its arrival, it was the fastest human-made object in history. To be captured by Jupiter's gravity instead of flying past it, Juno had to perform a nail-biting, 35-minute engine burn to dramatically slow down. This maneuver successfully placed it into a long, elliptical orbit around the planet. This unique polar orbit was ingeniously designed to keep the probe at a safe distance from the most intense parts of Jupiter's radiation belts for most of its 53-day loop, only to dive in close for a few hours to make precise observations. In August 2016, Juno completed its first scientific pass over Jupiter, capturing some of the most mesmerizing pictures of a planet ever taken. The enhanced images revealed a world far more complex and beautiful than we ever imagined, with deep blue cloud structures and storms unlike anything else in the solar system. Juno also used its infrared instruments to capture the stunning aurorae shimmering over the planet's south pole, phenomena normally invisible to our eyes. Jupiter possesses the most powerful auroras in the entire solar system, and for years, scientists were puzzled by their cause. Juno provided the answer, showing that unlike Earth's auroras, which are caused by the solar wind, Jupiter's are generated by powerful processes occurring deep within the planet's own atmosphere and magnetic field. Because of its unique diving orbit, Juno can skim incredibly close to the planet, sometimes flying just 3,100 miles above the turbulent cloud tops. This proximity allows it to gather the best possible data about Jupiter's hypnotizing clouds. The images it sent back revealed a remarkable, colorful, and complex tapestry of swirling, swelling clouds that violently roam all around the planet, a world with no solid surface to stand on. These gigantic cloud bands, mainly composed of ammonium salts, extend down for many miles into the atmosphere. Juno also gave us our first ever clear view of Jupiter's North Pole, revealing a massive, chaotic central storm surrounded by a stunningly geometric ring of 8 slightly smaller cyclones, each one nearly large enough to engulf the entire continent of North America. And of course, while exploring Jupiter, one cannot forget the Great Red Spot. This majestic anticyclonic storm, located 22 degrees south of Jupiter's equator, is one of the most iconic features in the solar system, having raged for centuries. In July 2017, Juno flew directly over the storm, capturing high-resolution images that revealed its grandeur in unprecedented detail. More importantly, Juno's instruments were able to plumb the Great Red Spot's depths, discovering that its roots plunge an astonishing 200 miles deep, nearly 50 to 100 times as deep as Earth's oceans. Beyond the clouds, the space probe directly mapped Jupiter's incredibly powerful and lumpy internal magnetic field, a landmark finding as it was the first time such a detailed map had ever been created for any planet beyond Earth. Initially, Juno's mission was planned to end in 2018, but given its incredible success and health, NASA has extended its mission to at least September 2025. In the coming years, Juno is expected to challenge old theories about the planet's formation, reveal the deeper structure of its atmosphere, and perhaps even give us our first glimpse into the nature of Jupiter's core. This means that for years to come, this intrepid spacecraft will continue to feed us with its enthralling observations, rewriting textbooks and forever cementing its place in the history of space exploration.